Okay, so we're slowing down this unit. We're only going to do one section per class. So instead of trying to do ellipses and hyperbolas in the same lesson, we're just going to do ellipses, which is probably a good thing because I don't know that I could have summarized ellipses and hyperbolas in a 30-minute, 2 videos, where ellipses is probably going to take 2 videos in itself. But know that next class, even though you're watching the ellipse video for homework, at the start of next class you're going to have a quick parabola quiz. So it'll only be on parabolas because you've already quizzed on the circles and distance formula and midpoint formula. Okay, so ellipses. What is an ellipse? Well, by definition it says an ellipse is the set of all points P in a plane such that the sum of the distances from P to any 2 fixed points is constant. Okay, so let's try to see what that means. We call the fixed points, here's more vocabulary, we call them each a focus. So plural form is foci. So 2 fixed points, they're called the foci. So let me show you what that is in this diagram. So here, this is foci 1, this is a fixed point, this is foci 2, this is a fixed point. Here's point P on my ellipse. Well, that's what the definition says. It says the distance between a point P that is fixed, here let's look at that definition while we're looking at the diagram. Sorry about that. Okay, so here's my set of all points P in a plane, and it's the sum of the distances from P to a fixed point and P to a fixed point. So notice over here, I said the measure of the segment P to F2, so that's this one, is 1.54. The measure of segment from P to F1 is 1.06, and the sum of those two together, right here, is 2.60. So here are my foci, here's my fixed point. Now, what happens? So if I animate this, notice this sum never changes, but that point in the plane keeps moving. And if that point in the plane keeps moving, but it's limited to this length being the same, right? This length always has to be the same. So animate. See how it never changes, but what does it create? It creates an ellipse. So now sketch that over here. So what do we have? Well, for the sake of our example, let's put our foci on the x-axis. So that means this distance here should be the same on the other side. So we'll call this foci 2. I have a fixed point, maybe wherever you want to put it, and these distances from that foci to the fixed point need to stay the same. So if I took a string and you pulled it back with your pencil, and you traced and went around, it's going to create something that looks like an ellipse. Or it is an ellipse. I shouldn't say it looks like an ellipse, it is an ellipse. That's the definition. So here are some other definitions that we need to know. So one is foci, one is center. So it says the center of an ellipse is the midpoint, so this is my center. And it is the midpoint of the line segment joining its foci. So right here, this line segment, if we calculate its midpoint, that would be my center. So in this case, I made the center the origin. But that won't always happen. We will shift our ellipse off of the origin, which isn't difficult. Okay, then we have a major axis and a minor axis. So the major axis of an ellipse is the chord passing through its foci. So the chord, that means it has to go from the leftmost point all the way to the rightmost point of an ellipse. A chord starts on a circumference and goes all the way through to the other side. So it starts on the edge. So this is the major axis. And the major axis is always the longer axis. Okay, so that's a good thing to remember. Your major axis is always your longer axis. In this case, it's my horizontal axis. Okay, then the minor axis is the axis that goes up and down in this case. So the minor axis is the chord containing the center. So notice they always need to go through the center. And it's perpendicular to the major axis. So this is going to be my minor axis right here. Right, so this is my minor axis right here. Goes from here to here, so it's my minor axis, and I guess really I shouldn't have drawn the major axis outside. This is my major axis. It was just hard to see those colors. So that's your major axis. So your minor axis is shorter, your major axis is longer. Okay, now how are we going to define an ellipse? Well, it's already been defined for us. We said it's the distance between a foci and a point on the edge of the ellipse. Between the foci and the point, those two distances added together are going to be constant. If I named that constant, so if I said it had to be 10 centimeters, then that means if I added, this is point P, right? If I added the distance from P to F1 plus the distance between P and F2, that should be the same value, and I'm going to give that a value of 10. Now let's see what happens using our distance formula. Okay, so this time I'm saying, let's imagine the foci were on points 4, 0, and negative 4, 0. So up here in my diagram, we would then say this is 4, 0, and this is negative 4, 0. And I'm telling you that the distance, or these lengths, these two things added together is 10. So let's do it. Let's put it in our distance formula. So P is unknown. That's what we don't know. So we say the distance between P and F1, right? So x minus 4, the quantity squared, plus y minus 0 squared. Well, y minus 0 squared is just y squared. Plus x minus negative 4 squared, which is going to turn into a plus squared, and y minus 0 squared is just y squared, will equal 10. Okay, well this is going to be a little bit gross, so what are we going to do? We have, in order to get rid of our radicals, we usually square both sides. But we can't square this giant radical because there's a plus sign separating it. So the first thing we usually do is move one of them to the other side. So my next line would be the square root of x minus 4, the quantity squared, plus y squared, equals 10 minus the square root of x plus 4 squared plus y squared. I need to start writing smaller, so should you, because we're going to need a lot of space. So now my next step is to square both sides. Okay, the left-hand side squared, that's super easy. You just write what's underneath the radical. So it's x minus 4, the quantity squared, plus y squared equals. Now actually, to save some space, I'm going to go ahead and FOIL the x minus 4 squared. So that becomes x squared minus 8x plus 16. Right, so this became this right here, and then plus y squared. On my right-hand side, that's a bit more of a nightmare. I've got to FOIL 10 minus this radical times 10 minus this radical. Okay, so 10 times 10 is 100. Negative 10 times the radical times negative 10 times the radical is negative 20 times the radical. And then finally, a radical times itself is just the radical times itself. Okay, to save time and space, I'm going to expand x squared plus 8x plus 16. So I've written out this radical here. Now, nicely, at least some of these things cancel. X squared cancels with x squared. Y squared cancels with y squared. 16 cancels with 16. However, positive 8x and negative 8x do not cancel because they're opposite signs. So this is a negative right here, so I'm going to move this to the left-hand side to make it positive. So 20 times the square root of x plus 4, the quantity squared plus y squared, equals 100 minus, or sorry, plus actually. I'm going to move the minus 8x over here to join this 8x, so I have 8x and 8x is 16x. So I bring down my 100, I have 16x, I move this to the other side. Okay, to make my life a little bit easier, I'm going to divide these numbers by 4, just because it's going to be easier when I square both sides again. So this would become a 5, right? I'm dividing everything by 4. This would become 5 times the square root of x plus 4 squared plus y squared equals 25 plus 4x. Now I've got to square both sides. And in order to save space, I'm going to continue this stuff up here, right? So I'll continue up here. So I square both sides. So on my left-hand side, I have to square 5 squared, which is 25, and then I have to square the radical. Well, squaring the radical gets rid of the radical, So that just becomes itself. On the right-hand side, I can write 25 plus 4x, the quantity squared. Okay, but now I need to expand all of this stuff. So 25 equals, so I'm going to expand this to x squared plus 8x plus 16, and then the y squared just comes down. And on the right-hand side, I need to expand this. That becomes 625. 25 times 4 is 100, but we have two of those, so that's 200 plus x squared. Now I have to distribute, okay, that's 25x squared plus 200x plus 400 plus 25y squared. And that equals 625 plus 200x plus x squared. Okay, so I'm going to erase this, sorry, so I can keep going over here. So the 200x's cancel, well that's nice, at least something does. I'm going to move my x squared, oh sorry, I made a mistake up here. This is 16x squared, sorry about that. So this is 16x squared. So I'm going to move my 16x squared over here by subtracting 16x squared. And I'm going to move my 625, actually no I'm not going to do that. I'm going to move my 16x squared over here, so I get 9x squared plus 25y squared, and I'm going to move my 400 over here to get 225. Your final way of getting something in the form of an ellipse is you need to have a 1 on the right hand side, so we divide everything by that number, which is 225, and then you reduce each fraction. So we have an x squared up here, we have a y squared up here. 25 times 9 is 225, so I have a 25 in my denominator, and I have a 9 in my denominator. So my major axis has a length of 5, and my minor axis has a length of 3. Okay, well how do I know that? You'll see that over here. So we have 4 intercepts based on that information. So what was it? It was x squared over 25 plus y squared over 9 equals 1. This represents my major axis. So here we go. So the square root of this the square root of this will give me my 2 intercepts on the major axis. And the major axis is related, if the bigger number is here, the major axis is here. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So that's my intercepts. I have an intercept of 5, 0, and negative 5, 0. And then the minor axis is my y-axis, so here you take the positive and negative square root of 9. So I go up 3 and down 3, so my other 2 zeros are 0, negative 3, and 0, 3. And then I connect those, and that's my ellipse. So that's how easy it is to draw. My center is at 0, 0, because I didn't subtract or add anything to x or y. So my center's at 0, 0. It goes to the right and left 5 units, up and down 3 units, and that's the graph of this ellipse. Now for identifying the domain and range, well, what is my domain? Let's do it in interval notation. The most left it goes is negative 5, the most right it goes is 5. It does include both those values, so that is my domain. Because there's no x in there, I need to identify that that is in fact my domain. My range is equal to, well, the lowest it goes is negative 3, the highest it goes is 3. It includes both those values, so it just has a bracket on both ends, lowest number first, highest number second. So my domain is from negative 5 to 5, my range is from negative 3 to 3. Now, is an ellipse symmetrical? So yes, it's symmetrical. It is symmetrical with respect to the x-axis in this case, right? So vertical line, right? So it's x equals 0, or it's symmetric with respect to the y-axis. Or in this case, it's going to be y equals 0 and x equals 0, those lines. So your lines of symmetry will rotate or switch based on where that ellipse ends up. When the origin is at 0, 0, or sorry, when the center's at the origin of 0, 0, then your lines of symmetry are x equals 0 and y